Can we do number 11?
Yeah. Okay, find the vertex and axes of symmetry of the graph. All right, we have here number 11, f of x equals 2x squared minus 8x. Now it says to find the vertex and the axes of symmetry, but I always like to find the axes of symmetry first. So in the axes of symmetry, and we'll just abbreviate it AOS for axis of symmetry. The axis of symmetry equation is negative b over 2a, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant, but we don't need c in the axis of symmetry. So we look at a coefficient of x squared, and that's 1. So, and I like to label these parts off to the side. The coefficient of x squared is 1. Coefficient of x is a negative 8. So you use the sign, and the sign is included in the coefficient. So this minus is the minus for the equation for the axis of symmetry, but then for b, you also have to include the other negative, so it's minus a negative 8. So the sign for the numerator is always opposite of what's in the equation. And then 2 times a, which is 1. And so minus the opposite of a negative 8 is a positive 8, so that becomes a plus 8. And then we can cancel, or 2 can divide into 8, right? 4 times. 2 divides into itself once. So we get 4 over 1, which is just 4. Okay, so our axis of symmetry is x equal to 4. So if we were to look at this graphically, okay, you would have this imaginary line at 1, 2, 3, 4. And this axis of symmetry is like a mirror. However many distance away the points are on the curve from the right side of the axis of symmetry is going to be the same on the left, no matter where the curve is. So now that's our axis of symmetry. So that's step 1. Step 2 is to find the vertex. And the way we do that is we take what we found in the axis of symmetry and substitute it back in for x, and we find the y component. So far in our vertex, we know what x is, or usually, typically for vertex, we use hk for the vertex, and any other point is xy. So 4 is the h component to the vertex, but we don't know what the y part or the k part is. So we'll just put a question mark there. So that's what we're trying to find now. So you take 4 and we substitute back into our function to find the vertex. So this will be 4, and then where x is, we cut that out and put 4 in there squared minus 8, and then where the x is, put parentheses, and we put 4 in there, substitute 4. And so 4 squared is 16, minus 8 times 4 is 32. So 16 minus 32 is a negative 16. So our vertex is 4, negative 16. And so our answers are x equal 4, and our vertex is x equal negative 16, 4, negative 16. Okay, questions with that?
No, sir.
All righty.
Pretty simple.
Yeah, yeah, yeah. It just helps to go back over these. Okay, determine without graphing whether the given quadratic function has a maximum or a minimum value, then find that value. Do we need to go over that one?
Yes, sir.
Okay, so let's go back to our board. So we want to find either maximum or minimum value and then find what that value is. Well, the way we do that is we look at our vertex. Okay, so here's our graph, right? And we know that our graph, let's say way down here is negative 16. We know that the graph opens up because the leading term is positive. If it were negative, it would open down. So it opens up.
And it opens up there. That means that there'll be a minimum.
That's right. This would be a minimum. So the minimum is always the y or the k component to the vertex. And it's located on the x or the h component. So the minimum is at minimum, or we could say minimum equals negative 16 is located at x equal 4. A little clear. X equal 4. So now they may write it differently, but basically it just comes down to whatever the vertex is.
But I thought those problems were two different problems, though.
Is what?
I thought those problems were two different problems.
Um, yeah. Well, I mean, it's the same equation, right?
Uh,
I believe it is. Let me double check. Maybe it's different. Oh, this one's a plus. Oh, okay, this is different. All right. So, all right. So that was the minimum, and that was the minimum value and the location for uh, number 11. So let's do problem 12, and we'll find that one. So the process is going to be the same. You have to find the vertex, and then once you find the vertex, then you can find the minimum, look to see if it's opening up or down. And then from there, um, here it is. From there, you can determine either your minimum or your maximum. Okay, so 12, we have here f of x equals to 4x squared plus 8x. So do we need to go over 12, or are we okay?
12, you're going to find the axis of symmetry. You're going to plug it back in to find the vertex.
Right.
Then you'll use your minimum or maximum to, if it's a plus, it opens up, right?
Yeah. So so
So
let's go ahead and do this one because it'll just give us more practice uh, overall. So we'll go ahead and do this. All right. So first thing we do is find the axis of symmetry, right? X equal to negative b over 2a, where b is 8. So this will be negative 8 over 2 times a is 4, right? Because if we looked at a and b, a is 4 and b is 8. Okay? So this will be, this will be 2 times 4 is 8, right? So this is negative 8 over 8. So this will be negative 1. So our axis of symmetry is at x equal negative 1. And it helps to do a rough sketch of what we have. Okay, I like to see things visually. So this is what we're looking at so far. That's our axes of symmetry. And this is positive, right? So we know it's going to open up. So that's another piece to the puzzle. So that means we're dealing with a minimum, right? Because it opens up, we're looking for a minimum. Okay, so now, like you said, we go ahead and we substitute the axis of symmetry back in for x to find the vertex. So our vertex, we know, is -1, but we need to find the rest of it. Okay, so we substitute that back in. F of -1 equal to 4 times -1 squared plus 8 times -1. And so we square first, right? Order of operations, square. So -1 squared is 1. 4 times 1 is 4. And then 8 times -1 is a -8. So we get a -4. So our vertex is -1, -4. Okay? So this would be -1, and let's say -4 is about here. So we know it's going to do that, right? So that means our minimum is what?
Our minimum is -4.
That's right. -4, and it's
Located
located
at -1.
right at x equal -1. Very good. You got it. All righty. Any questions at all about finding the minimum or maximum?
No, sir.
Okay. Okay. Find the 13. Find the vertex and axis of symmetry of the
Yes,
graph.
sir. I'm good.
We're good. Okay. Excellent. Determine without graphing whether the given quadratic function has a maximum value or a minimum value, and then find that value. Same
Good.
process.
I'm not same thing.
Yeah, same thing. Okay, good. All right, 15. Evaluate the expression using the values given the table. Okay, so this has to do with composite functions. So basically, we need to see that one.
Yes, sir.
All right. This is number 15. We have F. So this would be written as F composed with G. And 4. And I'm going to redo this table here. So we got 1, 6, 8, 12. And -4, 8, 3, 14. And then G of X -5, -4, 1, 4, 1, -7, 6, 8. Now, I don't like to call it the real world. I call it the working. In the working world, you may see something like this. When I was in the Navy, the pilots would use like tables and graphs and charts to pre-flight with, and so you may see something like this as far as something that's done on a routine basis, to where people would refer to graphs, and that's something that they see quite often. Okay, so this is something that you may see, maybe not necessarily with composite functions, but in general. Okay, I like to rewrite composite functions as f and then the g, the first part is always on the outside, the second part is always on the inside of 4. Okay, so you're always going to do the second part or the inner part first. So you find g, so you're looking for, first thing you're doing is you're looking for g of 4. Okay, and so whatever that output is, so you look at g of 4, okay, which is 8. So equals 8. Okay, so with this function, when you substitute 4 in, you get 8 out. They don't show calculations, they don't show the polynomial. Okay, all they show is this graph. So whatever this is, whatever comes out here on this bottom line, goes back as an input for f. Okay, so this will be the input for f of x. So this, now we're looking for f of 8. Okay, so now f of 8, the output, so x, the input is 8. So the output for f of x is 3. And that's our answer. Okay?
How did you get the 8 again?
You start with this number here, the 4. Okay? So that's the input for g, right? So this x, this is the input for g. This is input, output. So this is the input for g. This is the output for g. So the input for g is 4. The output for g is 8. So the output for g of x is going to be the input for f of x. So this is the input for f of x, the output for f of x. So what's out, this number is going to be the same number that's going to be going into f of x. Okay, and that's what I was showing here. Okay, so whatever you have here, that's what's going to come out, and you get your answer is 3. All right, let's try. We good, or we need to see another one? I can do another one if you want.
I'm good.
Okay, all right, good. Okay, so that's kind of fun. All right. So number 16, for the given functions f and g, find the requested composite function value. Now here, we're doing algebraically what we did up here on 15 with these charts or tables.
Can
So
you do one?
yeah, of course. All right. So let me just copy this. 16, f of x equals to the square root of x plus 4, and g of x equals to 2x, and we want to find f composed with g at 1.
I don't see the board.
Yeah, I have to copy it down, so I talk when I write a lot of times, especially when I'm teaching, because it helps me out. Okay, so the composite function has a circle in it. Okay, that's different than this. This is f times g, but that's not, we're not multiplying, we're applying the composite function. So this would be f, again, I like to rewrite this as f composed with g of 1. And I just think it just makes clear, it more, to me, it defines more how the process that needs to be done. We have to find g of 1. Here it's, I could see where students might put 1 in the wrong function first. So, but this one, this makes it a lot. This makes it clear what the first step is. The first step is to find g of 1. So g of x is g is equal to 2x, right? So this would be 2 times 1. So we put 1 into the g of x function, and we get an output of 2. So the output of g of x is going to be the input to f of x. So this will be f of 2. Okay, so now we put that 2 into our f of x function. So that'll be the square root of 2 plus 4, and we get the square root of 6. Well, we can't, the factors for 6 are just 2 times 3, so we can't simplify the square root of 6. So this is our answer here, square root of 6. And we're done.
Why wouldn't you put plus or minus?
Good question. Because when you start with a square root, okay, you don't put plus or minus. But when you solve for, like, for example, let's say we had x squared equal to 4, right? An equation. Well, now we apply the square root, right? And now we put the plus or minus. Why? Well, because our answer is plus or minus 2. You have, because we started with x squared equal to 4, right? We have two possible answers. We've got x equal to negative 2, and we've got x equal to positive 2. So either one of these will equal 4. Because if we substitute them back in, right? Substitute negative 2 back in, right? We got negative 2 times negative 2 is 4. So 4, that checks. And if we substituted positive 2 back in, right, that checks. So the plus or minus is to include all possible answers that will make this equation correct. Okay? So that's why we use plus or minus. All right? So that's why this is not plus or minus, because we're not solving. All we're doing is we're just taking a square, we're just taking a straight, we're starting with the square root. So if we had y equal the square root of, let's say, 9, right? Not trying to solve, that's what we've got. No plus or minus. Okay?
Okay.
All right. And graphically, the square root of x squared equal 4 would look something like this. And basically, these two here are the x-intercepts. Okay? So that's another reason this would be negative 4 here. So this would be negative 2 and positive 2. All right, so that's another reason why it's plus or minus. Whereas here, this is just a single point. Okay. All right. So, or actually, I suppose we could even look at it like this on the horizontal line at 3, like that. Okay. So enough of that. So we good there?
Yes, sir.
All righty. Okay, so 17. 17 is basically the same thing as 16, same process. So do we need to go over that, or are we okay there?
Okay.
All right. Number 18. Find the domain of the composite function.
Yeah.
So, okay, so basically this is kind of a two-part process here. All right, so f of x. Now, one is a linear function, and the other is a rational function. So basically, if we, okay, so now we're trying to find domain for f composed with g. All right, so let's go back to the board. And now the thing about composite functions is if both are all real numbers, if the domain for both functions are all real numbers, then the composite function is going to be all real numbers. If one's all real numbers and the other one isn't, then it's going to be, you have to look at the domain for the second one. So, but we need to go ahead and find what that composite is first, and then we can find the domain. All right, so first thing we got to do is find the composite function. F composed with G. So that means this will be F and then composed with G of X. All right, again, I like to rewrite the composite function because here it shows that G of X is going to go into F of X. All right, so if we run out of time, we'll just come back to this same link. All right, so it's like we're cutting out. It's like we're cutting out the x and we put parentheses. Okay, so this will be f and then parentheses equals 2 and then x. So the outside function is what we're working with, and the g of x, that's going to go into the f of x. So the x, we put parentheses, cut that x out, put parentheses, and then plus 10. Okay, now we're going to substitute in the g of x, 7 over x plus 6. 7 over x plus 6. Okay, so there's nothing to simplify here. So our composite function is going to be 7 over x plus 6 plus 10. Now, if we were to use transformations, we have basically this is a reciprocal graph where this is going to shift left 6 and up 10, right? So basically we know that domain is all real numbers, right? Except where two cases, right? For what we're working with. And what were those two cases? Except when x is in the what? Denominator. You there? And when
Hello?
x, yeah, okay, good. I thought, I wasn't sure if I lost you. Except for when x is in the denominator, or when x is in the radical, right? If x is in the denominator, then we set it equal to 0, then solve. If x is in the radical, then we set the radical, the radicand to greater than or equal to 0, then solve. Well, here x is in the denominator, right? So we just set what's in the denominator equal to 0 and then solve. So x cannot be -6, because if we put -6 in here, right, we got a -6 and a +6, that goes to 0 and we get undefined. So our domain is all values in set x such that x is everything except -6. So basically, it's like we put a hole here. The domain is everything else except for -6. Okay? And if we were to draw it graphically here at -6, you get a vertical asymptote, and then it goes up to 10, and that's a horizontal asymptote. So the graph is going to look something like this. So everything else is covered in the domain except for at -6. But the only thing you have to be concerned about is taking that denominator and setting 0 and solving, and then it's not that. Okay? Questions? If it was two
Oh,
rational functions, then it'd be a totally different process, but we're not doing those, so we're okay there. Oops, wait a minute. Nope, I didn't want that. Where's my... Oh, okay, there we go. Okay, so indicate whether the function is 1-to-1.
it is.
Good. Decide whether or not the function are inverses of each other.
I would say no.
Basically, you use composite functions, and f composed with g, and if everything cancels and you get x, then they are inverses.
Oh, okay.
Yeah,
So is that it?
that's it.
Uh,
Oh, wait a minute. No, there is more. Okay.
oh,
Yeah,
that's the
that's
log.
all for 20. Yeah. So you do basically you put f composed with g or g composed with f, and everything should cancel, and you just get x.
I think I'm pretty good with the logs
Good.
because I got good scores on the homework on it, so I feel comfortable with it.
Okay. All right. Next, change the exponential expression to an equivalent expression involving a logarithm. So basically, you're just going from exponential form to logarithmic form.
Okay.
And you just look at the base. You start with the base of the exponent, and you put that first for your base for your logarithm, and then you just switch the 2 and the 36 on the opposite sides of the equal sign. We good there?
Yes, sir.
Okay. Right as the sum and or difference of logarithms. Okay, here we expand it. If you're dividing, you're going to subtract it, and you got to bring those exponents down. If you're multiplying, then you add them. Do we need to go over that?
Yes, sir. I got a good score on my homework. I feel pretty comfortable with doing the logarithms.
You what?
I said I got a good score with the logarithms on
Good.
my homework, so I feel pretty comfortable with the logarithms.
Excellent. That's great. Okay, if you get a handle on logarithms, you should do pretty well. Give the equation of the horizontal asymptotes, if any. Basically, you look at the leading terms. If the exponents are the same, then the horizontal asymptote are the coefficients to the leading term. So in this case, it'd be 5 over y equals 5 over 4. We good there? We need to go over that.
We're good.
Okay, excellent. So the equation for this, we are going to apply log to both sides, and then solve it from there. So, and once we apply log to both sides, then we bring the exponent down. So the whole point of logarithms is it's the inverse operation of the exponential function. And with logarithms, you can bring that x that's as an exponent down. So do we need to go over that?
Yes, sir.
Wow, okay, excellent. Okay, give the equation of the horizontal asymptote. Basically, here you're using division. You're dividing polynomials.
Yes.
We okay?
Yes, sir.
All right. Find the inverse of the function in state, domain, and range.
I think we went over that earlier.
20, you want to go over 25 or 26?
Um, we do 26.
26. Okay. So basically, with 26, all you do is you just switch the x and y coordinates and then state what the domain and range is for the for the inverse.
Okay.
Okay. So we good there? Or do you want to see that?
I'm good.
Okay. Let's see. Given the equation of the horizontal asymptote, if any, give the equation of the horizontal asymptote. Again, look for the leading terms. Find the equation of the horizontal asymptote. You look at the leading terms. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If they're equal, then you look at if the degree of the numerator is the same as the degree of the denominator, then the horizontal asymptote are the coefficients. And if the degree of the numerator is greater, then there is no horizontal asymptote.